All right, in this video, I'll do the last two problems from the 2022 exam. So for number 5, we're given this differential equation. I won't read it out loud. Let f of x be a particular solution to that differential equation with initial condition f of 1 equals 2. We're told that f is defined for all real numbers. So A, we're given a portion of the slope field, and it just says sketch the solution curve. So this is really just understanding how to use a slope field. They've even put 1, 2 there. So I'm just going to do my best to follow the contours, follow them as well as possible, and keep going until you leave the region. Something like that is good enough. Just as long as you are drawing as much as you can, right, really from extreme left to extreme right, and are roughly following the contours, you're fine. It's just 1 point for a pretty good graph. Okay, now for part B, write an equation for the line tangent to the solution curve at a specific point. So if I want to find a tangent line, I need a point and a slope. So I will say point 1, 2. I'm just going to label that for my own edification. And now here, I'm just going to copy this so I can see it. So it would be on the same page when you're doing it. So my slope would be the value of dy dx. So my slope would be dy over dx, that measures slope of a tangent line, 1/2 sine of pi over 2 times 1 times the square root of 2 plus 7. So that's 1/2 times sine of pi over 2 times the square root of 9. Sine of pi over 2 is 1, square root of 9 is 3, and we get 3/2. They intentionally gave you numbers that are pretty easy to plug in. So my tangent line, let's just use point slope form, y minus my known y coordinate is equal to slope times, in parentheses, x minus my known x coordinate. All right, 10%, I think I can make it. Then it says use this equation to approximate f of 0.8. So for x equals 0.8, we would have y minus 2 equals 3/2 times 0.8 minus 1. Y minus 2 equals 3/2 times negative 0.2. You're not required to simplify as long as you get to your final answer, but here it's actually not going to be so bad. This is negative 0.3. And so y, which is f of 0.8, is approximately, squiggle is better, but it's okay if you just have an equal sign. That would be 1.7 after we move the 2 over. I will just pause to look at the official solutions so that I'm not doing anything crazy. Yeah. All right, part C. It is known that f double prime of x is greater than 0. Is the approximation we found an overestimate or an underestimate? This is one of these things we don't need to have memorized, just draw a little picture. So I'm going to draw a little picture here. This means that the graph of f is concave up. So if I have a concave up graph that's smiling, no matter where I am on a concave up graph, if I draw a tangent line, the tangent line is below the curve. So any approximation I get from the tangent line, if you imagine these are my approximations, they're actually below the corresponding points on the graph. And that's because the graph of f is concave up. So we could say, because f double prime is positive, the graph is concave up. This means that any approximation from a tangent line is an underestimate. You don't have to explain how you know that. You just want to very clearly put your finger on what information are you using. Second derivative is positive, means the graph is concave up, and I am confidently asserting I know this relationship about how concavity is related to tangent lines. Obviously, drawing the picture helps you understand this, but you are being evaluated on your words, not your picture. Now, finally, for part D, we are told to use separation of variables to solve this differential equation and figure out what f is. This one will not be easy, but it is doable. Just slow down and do every step correctly. So I have dy over dx equals 1/2 sine pi over 2x times root y plus 7. If I separate the variables, I will have 1 over root y plus 7 dy equals 1/2 sine of pi over 2x dx integral. I'm going to write this as y plus 7 to the negative 1/2. Now, both sides here are things that are technically u substitution, but I think they're both examples where you could get away with doing the chain rule in your head and just canceling with whatever number is necessary. So for this one on the left, when we have a negative 1/2 power, the antiderivative, we increase that by 1, would have a 1/2. We need a 2 to cancel that. But then our derivative from inside would just be 1. So we do want to think about chain rule, but we don't need anything extra. We'll just have a 1 there. That's my left-hand side. On my right-hand side, well, there's a coefficient of 1/2. I'll just leave that. Generally speaking, the antiderivative of sine is negative cosine. I would have negative cosine of pi over 2x. But if I took the derivative of this, by chain rule, my inner derivative is pi over 2. And I don't see a pi over 2, so I have to cancel that out with a 2 over pi. Let me just rewrite this. So I'm going to write this with a radical. That will probably be easier for solving. And then over here, I will notice the 2's cancel. And I could write this as negative 1 over pi cosine pi over 2x. And I forgot my plus c. As long as I remember it, can put it back right there. Always remember your plus c immediately at this stage. If you cosmetically put it in at the extreme end of the problem, it's probably in the wrong place. Let's solve for c. So I see that this is pretty ugly. It might be easier if I can figure out what c is right off the bat. So I have my initial condition. So I'm going to use x equals 1, y equals 2. So 2 times the square root of 9 equals negative 1 over pi cosine of pi over 2 times 2 plus c. So this is 6 equals, this is pi. Cosine of pi is negative 1. So this would be 1 over pi plus c. And so that means that c is 6 minus 1 over pi. A little bit ugly, but that seems to be what we're getting. I'm going to double check because, you know, this is a fair number and maybe something's going to cancel later on. But even for me, it's worth checking this. So this looks good. This looks pretty good. If I take the derivative here, the pi's cancel. Yeah, I'll get a 1/2. So I'm plugging in x equals 1, y equals 2, just double checking. So this is 6. Oh, x equals 1, aha. See, this is why we check when things don't look that great. I plugged in 2. Let's fix this. X equals 1. Right? Be a little suspicious when you get ugly numbers in the middle of a problem like this. Now we have cosine of pi over 2. Cosine of pi over 2 is 0. That's way more convenient. So we have 0 plus c, which means c equals 6. Much better. Right? Now let's continue the problem. So going back here, I have 2 root y plus 7 equals negative 1 over pi cosine pi over 2x plus 6. Now we just want to solve this for y. I will divide by 2. I will square both sides. And I will subtract 2. Let's just double check these last couple of steps. Divide by 2 looks good. Squaring both sides looks good. Oops. And then I just subtracted 2. So this would be our final answer. Let me check this against the official solutions. This one is not pretty. This will happen sometimes. Not everything is beautiful. Right? There are challenging problems. What did I do wrong? Oh, yikes. All right, so I would probably lose a point for this. Somehow, in my haste, this 7 turned into a 2. So let's just fix that. My apologies. Hopefully you won't make such a weird mistake. There we go. Sorry about that. Yes, so this was worth 5 points total. My guess is that weird copying error would cost me 1 point because I'm getting the final answer wrong. But in terms of demonstrating understanding of all of the steps, I would be getting those. Right? Basically, you get 1 point for separating the variables, just getting to this step that you know how to do it. 1 point for doing the integral on each side correctly. 1 point for figuring out C, and then 1 point for finishing the problem without doing something stupid like what I did. All right. All right, so even I made a mistake here. I would like to think that if I were working all by myself and used the full time, I would catch that. But, you know, you're going to make some small mistakes. Show your steps so that people know what you are doing and you get your partial credit. All right, finally, number 6. We have a particle P moving along the x-axis. And here we are given its position function, position of x. And we have particle Q moving along the y-axis, so that's a little different. Right? We have one of these is moving left and right, one of these is moving up and down. And also here we're told its velocity function. And we're given a specific piece of information at t equals 1. The velocity of that Q particle is 2. We will probably need that. All right, so A, find, okay, let's see if we can do this with 5% more. Find Vp of t, the velocity of particle P at time t. So velocity is the derivative of position. And let's make that clear. As obvious as you think that is, write it down. So Vp of t is the derivative of xp of t, which is 0 minus 4 times e to the negative t times negative 1 from the chain rule. So we get 4e to the negative t. For B, we want to find aq of t, the acceleration for particle q. So again, we're going to take a derivative. aq of t is the derivative of vq of t. Make that clear. Even if you think it's obvious, demonstrate your knowledge. And vq of t, we will note, was t to the negative 2. So this would be negative 2t to the negative 3, which is the same as negative 2 over t cubed. Then it says, find all times when the speed of particle q is decreasing. And we're only looking at positive values of t. Speed decreasing is something that we have usually described as slowing down. slowing down occurs when acceleration and velocity have opposite signs. Let's just note here, VQ of t, which is 1 over t squared, is always positive. AQ of t is always negative. Again, we're told to only consider positive values of t. So V and A always have opposite signs. So speed is decreasing for all values of t that are positive. Okay, and that's 3 points total. 1 for finding acceleration, 1 for demonstrating that you understand how speeding up and slowing down are involved, and 1 for getting to the correct answer. All right, C. Find the position of particle Q at time t. So what we know is the velocity function. So we want to work backwards from velocity to figure out position. So our position function would be an integral of our velocity function, which was 1 over t squared. So that's going to be negative 1 over t plus c. Right, this is t to the negative 2. I did that somewhat quickly. Now we had a piece of information that we haven't used yet. We're told that the position at time 1 is equal to 2. So if I plug in 1, I get 2. So that means negative 1 plus c is equal to 2 and c is equal to 3. So my position function is negative 1 over t plus 3. And then finally, with 4% to go on battery, let's see if I can do this. As t approaches infinity, which particle will eventually be farther from the origin? So let's think about the limit of the position function. So the limit as t approaches 0 of xp of t. Let's find that formula. It was 6 minus 4e to the negative t. So it's the limit of this function as t goes to infinity. A really big negative power makes something really small. So we have 6 minus something really small. This limit is 6. We just found that the formula for y was negative 1 over t plus 3. The limit of that, well, 1 over huge is roughly 0, plus 3 is 3. So if we wait a really long time, the x position is almost 6. The y position is almost 3. So we can say, right, 6 is greater than 3 if you really want to put your finger on it, but I think everyone knows that that's obvious. So particle P, right, make sure you're naming it by which particle it is, will be farther from the origin. Okay, so with 4% left, I'm going to stop this video.